Yesterday you told it your name, your job, and exactly what you needed. This morning it greets you like a total stranger. Nothing is wrong with it. The machine that can write poetry and pass exams was built to forget you. Every conversation you have ever had with it, it has already lost. Not misplaced, erased. And here is the twist. The same design that makes it forget is what makes it work at all. To see why, you have to look at the only memory it has ever had. It is not a brain, it is a desk. So follow me inside, past the glass, past the light, into the place where your words actually go. Welcome to the machine's world. Every message you send arrives here, in a city that exists for milliseconds at a time. And at the center of that city stands the only room that matters, the model's working memory. Researchers call it the context window. Think of it as a desk of fixed size, standing in an infinite dark library. Everything the machine can think about must fit on this desk. Everything else, for the model, does not exist. Your conversation is not stored inside the machine. It is spread out, word by word, across this one surface. It is spread out, word for word, book across every scribble. Every word you type is broken into tokens, and the tokens are laid out on the desk in order. The model can only think about what is on the desk right now. Nothing beside it, nothing before it. Small models work at desks of 4,000 tokens. The largest stretch toward 1,000,000. 1,000,000 tokens sounds infinite, several novels at once. But watch what happens as your conversation keeps growing. Because the desk is not storage, it is working memory. Everything the model is looking at, all at the same time. On your side of the glass, all of this is invisible. You just see a helpful answer appear. But under every answer, that desk strains, under a law of mathematics that no engineer has ever escaped. The engine we met before, attention, means every token on the desk looks at every other token. And that little word, every, hides a brutal price. Watch what happens when the desk doubles. Double the desk, and the number of looks quadruples. 4 times the desk, 16 times the work. 64,000 tokens to 128,000, 4 times the computation. This is the quadratic wall. An unlimited desk would be unbearably slow and ruinously expensive. Every extra token costs compute, and compute costs money. Engineers fight the wall with clever tricks. Flash attention, sliding windows, grouped queries. The tricks help. The wall remains. So every conversation lives inside a hard limit. And when your words outgrow the desk, something has to give. Something falls off the edge, and the desk does not choose randomly. The oldest tokens go first. Guess what you told it first? Your name, who you are, what you actually wanted. Now step back outside, into the morning, and watch what that looks like from your side of the glass. You are an hour deep into planning a trip together. Dates, budget, the little hotel by the harbor. And then, mid-sentence, it asks, so where are we going? An hour of planning, gone from its world. The model is not being rude. Inside, the oldest tokens slid off the desk, while new ones piled on. It literally cannot see what fell. The words are not hidden. For the machine, they no longer exist. Some apps quietly fight back. They summarize the past to save space before it falls away. Your rich, detailed hour becomes 3 pale lines. Better than nothing. A shadow of what you said. And when you close the chat, it gets worse. The desk is swept completely clean. Nothing you said enters the model's weights. Its learning ended long ago, in training. Conversations never teach it. The robot sweeps the desk each night, and the library behind it never gains a single new book. Tomorrow morning, you are, mathematically, a stranger. Again. Same you. Same machine. Blank desk, which raises the obvious question. Sometimes it does remember your name across weeks. So how? Because engineers stopped trying to grow the desk and bolted memory on from the outside instead. When an assistant remembers you, the model did not learn it. A separate system wrote it down. A notebook outside the brain. Before each new chat, relevant notes are retrieved and quietly placed on the desk. The model never truly knows you. It reads notes about you before replying, every single time. The same trick lets it read documents it was never trained on. Fetch from outside, place on the desk, answer. Researchers call it retrieval augmented generation. The desk stays small. The world around it becomes the memory. In 2026, the pattern went further. Teams of small agents, fetching and checking notes in parallel. So, memory, it turns out, was never inside the machine. It is a filing system built around it. And the forgetting we started with? That was the design all along. A clean desk is what makes it work. Which leaves the question that actually matters. What should you do differently now that you know? First, the start of your conversation is the most fragile part. What falls off the desk falls from the beginning. So when it matters, restate it. Put your name, your goal, your constraints back on the desk. Second, long conversations drift because the desk overflows, starting fresh and re-anchoring beats scrolling on. Third, memory features are notes, not knowledge. You can usually read, edit, and delete what it knows about you. Fourth, nothing you say teaches the model. The amnesia that frustrates you is also protecting you. So the machine that forgets you every night is not broken. It is honest about what it is. A desk, a wall of mathematics, and a notebook, doing their best impression of a mind. And once you see it that way, every strange thing it does starts making sense. Tomorrow it will greet you blank again, but now you know exactly what to put back on the desk. The desk explains one more mystery. Why running these machines costs so staggeringly much money. Where all that money actually goes. The hidden economics of artificial intelligence. Next time.